Hi, brothers and sisters. How are you doing? I'm Michelle, and I'm continuing to read Jim Stevens' book that he wrote. It is called 101 Proofs for God. And I like to say 101 Proofs for the Absolute Existence of God. Yeah, once you start reading these, you'll just have your mind blown. It's an incredible book. Yeah. So I am reading The Proof for the Absolute Existence of God. It's number 97, and it is called the Retina. Okay. In doing research for my next proof for God, I came across a quote that blew me away, Jim says. I had never heard any detail like this about the retina of your eye, even though I had already written one whole chapter about the eye, and that's proof number 45. As you know, the retina of your eye is the part that allows you to be able to see this page or anything else. It is full of nerve cells that convert light into electrical and chemical signals that are sent to the brain down the optic nerve. Your retina is thinner than saran wrap, by the way. I find what it does really hard to imagine. Here is the quote. It is clear that the human retina's real time performance goes unchallenged. Actually, to simulate 10 milliseconds of the complete processing of even a single nerve cell from the retina would require the solution of about 500 simultaneous nonlinear differential equations 100 times, and would take at least several minutes of processing time on a Cray supercomputer. Keeping in mind that there are 10 million or more such cells interacting with each other in complex ways, it would take a minimum of 100 years of Cray time to simulate what takes place in your eye many times every second. Wow. You could quibble and say that this is an old quote, which it is, from about 1985. But even given that computers are a lot faster now, it would still take a supercomputer like big in size and needing lots of power to do what your tiny little retina is doing every second, in each eye, of course. Researchers at UC Berkeley discovered that our retinas form a stack of 10 to 12 different image representations of what we view by using crosstalk between different layers of cells in the retina. And this is the thickness of saran wrap. Can you imagine different layers within that? The images are not very good quality, but they are all sent to the brain, and the brain assembles them into the wonderful images we experience. No person in their right mind who knows what a computer chip is would ever proclaim that it could have evolved. Yet some very sane people refuse to see that there was any super intelligence behind the formation of a retina that is vastly superior to any computer chip. Vastly superior. And besides, retinas have been around for millions of years. The retinal rods and cones are composed of various layers. The human rods have a dynamic range of about only 10 billion to 1. In other words, when fine tuned For high gain amplification, as when you are out on a dark night and there is only starlight, your photoreceptors can pick up a single photon. Phenomenal sensitivity. Of course, the retina does a number of processing tricks on on that on that just to make sure it is not picking up noise or false positives so you don't see static. It really wants at least six receptors in the same area to pick up the same signal before it believes that it is true and sends it to the brain. Wow. In bright daylight, the retina bleaches out and the volume control turns way down for, again, admirable performance. Take note that your retina can pick up a single photon of light. That's how sensitive it is. But just to be sure, there are no mistaken electrical impulses sent to the brain, the retina makes sure by checking around and only sending a signal if six photoreceptors all pick up the same thing. A retina that sensitive, if exposed to sunlight, would get totally bleached out and you wouldn't be able to see anything. However, your retina is able to adjust to major changes in the amount of light. Imagine how that could possibly evolve. And remember, all this ability is contained in something thinner than saran wrap. Note also that the retina is transparent. You can see right through it. That's just the tip of the iceberg. Just about everything about your retina is a profound miracle. I mentioned above that the dynamic range sensitivity of the retina is about 10 billion to 1. For modern photographic film, we are only talking about a range of 1,000 to 1. Think some more about a computer chip when compared to your retina. Remember that the computer chip was absolutely designed by some very smart people. The retina only occupies 0.0003 cubic inches of space, and the power consumption of the retina is about 0.001 watts. The retina has a resolution of about 10,000 by 10,000 pixels. It has about 25 billion equivalent gates in it that are like the transistors in a computer chip. Other parts of the retina are equally miraculous. There are 3 layers of cells on the back of the retina: the retinal pigment epithelium, the choroid, and the sclera. The retinal pigment epithelium is a multifunctional and indispensable structure. The RPE is a single cell thick tissue layer consisting of relatively uniform polygonal shaped cells. These cells touch the extremities of the rods and the cones, the photoreceptors, with dense microvilli and basal membrane enfoldings. Okay. Posterior to the RPE is the vascular choroid layer, which is filled with blood vessels that supply oxygen and nutrition and remove waste. The structure of the choroid is generally divided into 4 layers, classified in order of furthest away from the retina to closest. Number 1, Hayler's layer. This is the outermost layer of the choroid, consisting of larger diameter blood vessels. Number 2, Sattler's layer. This is a layer of medium diameter blood vessels. Number 3, chorea capillaris. Chorea capillaris, sorry. And this is a layer of capillaries. And number 4, Bruch's membrane. Sorry, it's a German word. Sorry about my pronunciation. And this is the innermost layer of the choroid. Note that your retina has small blood vessels, medium-sized, and also larger blood vessels. These are all necessary for the correct functioning of the eye. It's incomprehensible that this emerged by evolution in a slow and gradual process. The fossil record constantly shows only animals that have fully formed eyes. Posterior to the choroid layer is another layer of connective tissue known as the sclera. Evolutionists like Richard Dawkins, Kenneth Miller, Daniel Dennett, and others have claimed that evolution is proved because the retina of the eye is backwards. They say this is a poor design. Wow. Because the rods and cones are facing away from the direction where light enters the eye. The retina was even called functionally stupid. Their proof is that they know better how the retina should be correctly designed, and we would have better vision if our eyes were like squid's eyes. Since it's a poor design, it must have evolved because they know if there were a God, he would not have done it that way. He would have done it another way. A flawed design is their evidence against the Creator God and an argument for a random process of mutation. So, what if scientists, upon further research, can prove it is not a flawed design, but actually the best possible engineering? Could we then proclaim that there is a God? Would the atheists be forced to change their minds? Well, as it turns out, that is exactly what has happened. I knew that was coming. Many researchers have discovered that the design of the retina is actually the best design, and that there is no evidence that the evolutionists' idea of the best design would even work at all. I'm not going to spend a lot more time on this, Jim says, but I want to point you to a fantastic technical paper that goes into all the details of why the design we have is perfect. If you are interested, read the article called "Why the Inverted Human Retina is a Superior Design." And the title of that again is "Why the Inverted Human Retina is a Superior Design." And it was written by Jerry Bergman and Joseph Calkins. Here is a short list of some of the reasons why the design of our human retina is actually the best design and was clearly designed by an all-knowing intelligence. Number 1, rods and cones need a lot of blood. Rods and cones require a greater blood supply than any other bodily tissue. Wow. They require close contact with blood in order to receive oxygen and nutrients. Waste products need to be carried away. Vision actually happens because chemical reactions are taking place and sending signals to the brain. Heat is being generated that needs to be cooled by the blood. Photopigments constantly have to be replaced and recycled. Rods and cones, photoreceptors they're called, get used up and have to replace themselves about every 7 days or so. Number 2, best location of blood supply. If the retina were designed in the opposite way, where would the blood supply be? You can't put in front of the rods and cones. If you put it along the sides, it would take up too much space and reduce the number of rods and cones. That would cause poorer vision. Number 3, need an opaque layer to absorb excess light. The rods and cones need to be close to a dark surface to absorb stray light. Otherwise, reflecting light would distort our vision. The retinal pigment epithelium provides that dark surface. Wow. Number 4, retinal pigment epithelium needed. This layer of cells produces critical enzymes for vision. It also stores vitamin A for regeneration. Wow. This diagram is just really incredible right here, and I know, it just doesn't do justice to show you this picture here on the computer. But that is why you've got to get the book, because the diagram is just incredible. Okay? The RPE also helps maintain water and ion flow between the neural retina and the choroid, protects against free radical damage, and regulates retinoid metabolism. It is also a barrier to protect the inner parts of the eye. Number 5, retina should not be more sensitive than it is. As I mentioned above, the retina can recognize a single photon of light. You cannot get any better than that. Our retina works better than any other design. If there were somehow greater sensitivity, you might see too much and then you get blinded. It might be helpful at night, but not at all during the day. It would cause more eye damage too. Why do you think people wear sunglasses? Number 6, Mueller cells. Recent research has discovered Mueller cells in the retina. These are actually like funnels that help carry the light through the retina so it is less distorted. They have the perfect index of refraction to transmit the light with minimum loss and distortion. It's like God invented fiber optic cables thousands of years ago. How about that for design? 7, light does not get blocked. Amazingly, very little light is actually blocked by the part of the retina the light encounters first. This is the transparent layer of many nerve cells leading to the optic nerve and then the brain. Normal nerve cells are covered with a substance called myelin. But the nerve cells in the retina do not have this covering, which would have blocked some of the light. Also, the large blood vessels and nerves inside the eye travel around, but not over the area where your focused vision takes place. What a good design. Number 8, waste must be carried away. There are waste products from the chemical reactions as well as the dyeing rods and cones. If the rods and cones faced the front, all the garbage would accumulate inside your eye. The result of that is obvious. 9, fast recycle time. You know, if you drive at night and look into the oncoming headlights, you are temporarily blinded. The close blood supply allows a relatively fast recycle time. If your rods and cones face the other way, you'd be temporarily blinded much longer. 10, color and much greater detail than squid eyes. Research on squid eyes shows they can perceive shape, light intensity, and texture, but any details are seriously lacking. Squids have only 20 million receptor cells in their retina, whereas humans have 126 million. Squids have only rods, whereas humans have rods and 3 types of cones, allowing us to see the whole color spectrum. Wow. 11, momentary shadows are a good thing. It turns out that the light having to pass through various cells before getting to the rods and cones is a good thing. Constant light would bleach out the rods and cones, but the momentary darkness gives them a break and allows them to regenerate. Think again about sunglasses. So we can now conclude that there is no poor design here at all. In fact, the design is so magnificent, it is beyond our understanding even. Wow. So Jim says, there must be God. Yep. Okay. Thank you, everyone, for that. That's truly incredible. Thank you, Jim. And another thing about eyes that Jim didn't mention, they're so beautiful as well. Okay. All right. Take care, everybody. Bye.